All right, so welcome to today's video. This is going to be a part of the Practical Malware Analysis book, or the Alien book, by Michael Sikorski and Andrew Honig. And I will either link it in the playlist description or in the description of each video. Today we're doing lab 1-3 in the first chapter of the book, and the third lab of the chapter. So what we'll do here, and also big shout out to Let's Defend, because they have a virtual machine set up for Windows malware analysis, which we're in right now with all the tools that you will utilize. I have my own instance of Flare VM as well as Remnux, but I've been having issues. I have it on an external hard drive or an external SSD. I hooked it up to my new PC. I've been having issues with it being super laggy and freezing up on me. So I'm going to have to troubleshoot that. But for today, I'm on my MacBook, and it's a ARM processor. So it's one of their M series processors, and it doesn't go too well with Windows-based malware, that's for sure. I'm very happy that I have the Let's Defend subscription, and they allow this. So thank you, Let's Defend. And that's their background image, and I will link their site as well. So we could go ahead and delete these zip files that I downloaded, because what we have here is all of the labs from the GitHub repository you can find online by just doing a quick Google search of Practical Malware Analysis labs at GitHub. You'll find a couple different ones, and they should have all of the same. So here is the lab 1-03. This is, so this is the file we'll be doing the analysis on. First things first is to upload the file to VirusTotal. Does it match any existing antivirus definitions? Another great thing is that I was able to RDP into my session here. So which if you don't, you'll have a very small screen to work with. I mean, you can zoom in and stuff, but the resolution quality will definitely drop if you do that. But hey, it's an option, but I definitely am happy that they have an option for this as well. So again, we'll start with question 1. We'll open up Chrome. Let's go ahead, go to VirusTotal. We'll go ahead and just drag and drop this file, and we'll see when the last analysis was. It was 18 days ago, so we'll go ahead and reanalyze that. Actions for Trojan virus. And okay, so this is going to be new, but I do know that this FSG is a packer. So that's already a category that this is probably a packed sample. So we're going to have to unpack this. We'll have the threat categories, which is nice to see. Like we said, a Trojan, and it looks like to be spyware. The family labels for this are Graftor, Genome, and a Trojan Clicker. It was detected by 65 out of 72 security vendors. So we'll go ahead and copy that, and we'll answer the first question with that. So it matched 65 out of the 72 detections on VirusTotal from the 72 different security vendors that work with VirusTotal to allow the community to analyze possibly malicious software. Are there any indicators that this file is hacked or obfuscated? If so, what are these indicators? If the file is packed, unpack it if possible. So I already saw that there was the FPG hacker. I believe we'll reopen this and we can see FSG. So let's correct that FSG hacker. And based on that, we'll also take a look in the details. We'll go down to the virtual sizes, and we can see that these virtual sizes are virtual and raw size, which virtual is memory, raw is disk. We can see that they are very different, and that is a good indicator that we're dealing with a pack sample. So let's note that in our notes really quick. Virtual size and raw size high discrepancies of substantial. So the indicators are, we see that it's FSG packer, we see that the virtual and raw size of the sections are different. We can also take a look at the imports, and literally the only two imports in the kernel 32 dynamic link library. We have a function of get proc address and a load library function. Again, those are going to be normal for all Windows. Almost every executable, I believe, or possibly every single executable should have that standard. That is a big sign that it's packed, because even a hello world program would have more imports than just what we're seeing here. And I can also, so yeah, here's a note in the book. Packed and obfuscated code will often include at least the functions load library, which we see, and get proc address, which are often used to load and gain access to additional functions. So we're going to need to unpack this. And this is the first time I am working with a FSG pack sample. We'll have to go and look at our tools, which will open up the File Explorer, and we'll go to desktop. So with the techniques that I've learned so far in the book, we can't unpack this. I don't have the knowledge level to unpack this sample at my current level, but what we can do is, I know CFF Explorer has a dependency walker as well as a possibility of being able to unpack the sample, I believe. So let's take a look at this in here. And as again, you can see that FSG version 1 is an indication that this is a packed sample. It only has a UPX utility for unpacking. You know what? I'm gonna try to figure that out. What we'll do is we'll look up FSG unpack. I've been blocked by network activity. All right, Reddit. There's a whole malware analysis cookbook. So I'm assuming, based off of this O'Reilly Media Lab 18, we're probably going to learn how to unpack FSG. But still, let's try to see if we can. Okay. Someone did a write-up on this. Look, they actually, so I'm gonna, hold up. I'm gonna scroll up a bit so I don't see the import hints too much. But I want to see this unpacking, how to unpack this. But looking at their analysis again, take a look at the date was in 2013 and we're in 2024. So One is VirusTotal has a bunch more security vendor engines, and the longer the sample is are out there. So honestly, what we'll do for this, I would really like to be able to unpack this, but I'm just not sure how currently. But I'll see what tools we have. We'll do PE view, and we'll go on the desktop and we'll get that lab file, and let's look at the section headers, which all we can see is the load library still. Okay, so you know what I'll do? For now, we'll just answer this question. Unable to unpack sample at current skill level. And we'll cross-reference this with the book's answers at the end. So we'll go over those answers together as well to see how I did. Do any imports hint at this program's functionality? If so, what imports are they and what do they tell you? Well, all I know is that we have the git proc address and a load library, right? So with that, I'll take a look at appendix A, which actually, we don't even have to do that at this level because take a look. We already know that both of these indicate that the functions we see are used to load and gain access to additional functions. So that's not really what I was hoping to be able to get from this lab. So again, at the present moment, the file is packed with FSG and we are unable to unpack it to get more indicators at the current level. But what I do know is indication wise is we could get the hash. And again, we're only doing static analysis at the current moment, so we're not going to dynamically run this. Again, we can see it's FSG. If it was UPX, we could be using the CFF Explorer. Maybe it does have something that will allow FSG as well, but I'm not there yet. With that being said, we'll go ahead and look at the lab answers in the book to see how we did on this. I feel like this was supposed to be this way. The lab 1-2 I did yesterday was a UPX sample, and I was able to unpack that and get a lot more information. We haven't really dived into FSG. So again, lab 1-3, it says, for the short answers, as of the writing, which is a while ago, 25 of 43 virus engines identified this sample as malware. We had 65 out of 72 security vendors flagged this file as malicious in our case. The file is packed. So this is back to the book answer. The file is packed, but we cannot unpack it at this time. This question can't be answered without unpacking the file. This question, and number 4, same thing. This question can't be answered without unpacking this file. Okay, so, let's get on to lab 1-4 and see what we do with that. All right. So I'm going to pause the video here. Okay, and now we will do lab 1-04. So this is the last lab in the Practical Malware Analysis book for chapter 1. And get my notes pulled up and again get the questions in order here. So we'll have question 1, we'll have question 2, question 3, question 4, question 5, and question number 6. All right. So first things first, we'll be doing our first step of VirusTotal, which seems to be one of the best first steps to get an idea of what this file is doing. So I'm not going to reanalyze it since it was analyzed 1 day ago. We have 64 out of 72 security vendors are flagging this as a malicious file. So yes, it does match. It matches 64 out of 72 security vendors on VirusTotal. Are there any indicators that this file is packed or obfuscated? Let's take a look. Does not appear to be packed. Actually, this appears just to be a file that was written in Microsoft Visual Studio, our visual code with it's in the language C or C++. So we can also take a look at the sections. We do have discrepancies in these virtual and raw sizes though, but we definitely have a lot more imports here. So yeah, there's a lot of imports that indicate that this is not packed. So I'm gonna say this is not packed. No, not packed. Not a packed sample. When was this program compiled? The compilation date for this says 2019 on August 30th of 2019 at 10:26:59 UTC. So we'll take a note of that. So the program was compiled this date. Do any of the imports hint at this program's functionality? If so, which imports and what are they and what do they tell you? Our PID tool. And make sure if this looks like it's packed, and it's not, it doesn't come back with any type of packed. I don't see a packer. Okay, so with that, now I would like to open up CFF Explorer, and I would like to open that sample, and I'd like to go to the section headers, take a look at a few of these, the imports. You can see create a file, write a file. So I can see that this is going to create a file, and I'm going to have to look into my book in the appendix for some of these. So again, the create a file creates a new file or opens an existing file. So take note of that. WinExec, I was curious to actually know what that was, and it says used to execute another program. If malware creates a new process, you'll need to analyze the new process as well. So that's something to note. Let's see if we see a... So do we see a create process currently? I see an open process, and then it loads more resources, which adds up to what we've read so far. So let's take a look at the next. We have open process. We have a lookup privilege value, open process token. Okay. Let's take a look at dependency walker. So again, we can see the open process token and adjust token privileges after also a lookup privilege value. So I'm going to take a good guess that this is going to try to elevate privileges potentially based off the kernel 32 imports. You can see that it creates a file. It writes a file, creates a file. It's going to load more libraries, right? Find resources, get Windows directory, and then it moves a file to a temp path and then gets a current process and opens that process. So this creates a new file, moves the file after getting the Windows directory. So so I'm assuming that searches for Windows for the directories, right? But let's look in the book and see if we can find that get Windows directory returns the file path to the Windows directory, usually C drive Windows. Malware sometimes uses this call to determine into which directory to install additional malicious programs. So first, let's get that get Windows directory. We have the move file, and then I'll do even open process after it looks like it moves it to a temp path potentially, or it's going to move it to a temp directory. That's my guess at my current level. And then it loads resource. In the case of malware, though, winexec would tell us that it's likely used to spawn a new child process or execute more malicious payloads. Write file, which is going to show file creation. So this writes data to a file or IO device, opens, creates, or modifies a file or directory or device. So the create file opens, creates, or modifies a file, directory, or device. Get Windows directory, gets the path of the Windows directory. So that's pretty self-explanatory. Malware may use this function to locate the Windows system folder to drop payloads or DLLs into trusted directories, bypass security measures by residing in system directories. Move file can move or rename files. Malware could use that for file evasion by renaming critical files, moving payloads to hidden or system directories, and even overwriting malicious files. We have that open process. Opens an existing process for manipulation. Malware can use this for a process injection, code injection, or gaining access to already running process. This could indicate potential techniques like DLL injection, process hollowing, or even debugging or reading another process. We'll have a load resource, which loads binary or resources like executables image or data from a module. The next one will be the ones we found in the advapi. So the top 7 were the ones that I took note of from our kernel 32 DLL, and from the advapi DLL we can see the 3. I took note of all 3 here. So open process token, lookup privilege value, as well as token privileges. We'll start with open process token, which retrieves access, permissions, right? Lookup privilege value finds the value of a specific privilege. Adjust token privileges, adjust the privileges of a process. So again, we can like we said earlier, these functions are often used to escalate privileges or bypass access control measures. Common goals include enabling SE debug privilege for debugging system processes and gaining system level privileges for persistence or advanced operations. So for question number 5, we're going to want to look into the strings. So we'll take a look at the strings tool. Hey, I agree. All right, that's fine. I'm going to open this in a command line. So we'll change directory to desktop, and we'll run the strings on our lab 01-04 sample. Get GUI here? Yeah. No? Okay. All right, so I guess I'll change the directory into strings, and I'll run strings on the lab 01-04 executable. No matching files were found. Okay, so I'll try again, but I will put another dot. And there you go. Nice. All right. So take a look here. And a lot of this is just garble data. So I see a winlogon.exe. So I'm going to take note of that in the notes, as well as the SE debug privilege, because that, what I read earlier, shows that this may be trying to debug system processes. SE debug privilege. SE debug privilege. We have a DLL that I would like to take note of. This directory and that executable I would like to take note of as well. So this system32 wup dmanager.exe finally went up. And what I would like to know is, I don't know if winlogon is really a good indicator, because that's on like that's like normal to see. So I don't know if that would be a good indicator actually. So I'll delete that one for now. But if there's a way to tie it to this specifically, then so URL download to file, again, we're gonna note that it downloads a file. And also we have this malwareanalysis.com/updater. So this is a file it's going to definitely try to grab. And I'm assuming it's going to try to pretend it's some type of update, right? So that's a good network-based indicator. We could look and even just block that domain. Thankfully, though, this is part of the Practical Malware Analysis book, so none of this currently is. So we have a good network-based indicator, and then of course we have the We have the hashes that we can use as well as host-based indicators and to use for our blocks. But let's use resource hacker here. If we have that on this machine, I don't know if we do. Process hacker. So I can run this. I can run this, right? Yeah. I can run this because we're in a analysis environment. So this is made for static and dynamic analysis. Again, though, I am going to check to see if we do have that. If we do have resource hacker. And I don't think we do, but I can also just try to download that real quick, hopefully. So before I go ahead and execute that, I will upload this to another instance of VirusTotal to make sure that this is good to go. I believe that link is valid though. Possible threat, unsafe, Trojan banker, riskware. Okay, then I won't utilize that right now. I'll instead go to the soft tonic link, or you know what, maybe even Angus Johnson. I think that all that's happening here is that it's like a false detection. I'm not 100% sure. So we can use Process Explorer instead from Microsoft's sysinternal suite. We also have procmon. All right, let's download Process Explorer, run that, agree to the Microsoft sysinternals. I'm not even seeing that process in here. Type the name of a program or document or internet resource and Windows will open it for you. Okay. Thank you for that, but at the same time, I would rather just use the tool that we can use. But again, I'm going to run this resource hacker tool because I believe do that fine, because that is from the actual website. So again, I think those detections are kind of just tripping a bit, and we're in a safe environment to do it either way. So let's take a look here, and we'll open the file, which is going to be the lab 104. And we are going to look for this file as one resource in the resource section, use resource hacker to examine that resource, and then use it to extract the resource. What can you learn from it? So again, we can see it takes one, it does have one resource. The binary has one resource. What can I learn from this? What can I learn is I just learned that everything that we already just found leads to this winup.exe. Okay, so look, besides the garbled, all I can see is that this program cannot run in DOS mode. We have the MZ and the 4D5A indicating it's an executable. This looks like garbled mess to me at the moment, and it might be, but we have this as well. So I can tell that it 100% downloads a file. It sets an application type. It gets the main arguments. It loads in the URL mon DLL and MS. It exits set user mather. So and then yeah, 100% it goes to this http www.practicalmalwareanalysis.com/updater .exe, so down it gets that other executable, right? So it said extract that resource. I'm gonna rename this to lab01-04, and then I'll rename it to a .exe file. Yes. And that is an executable file now. So that is an armed sample. And then I'm going to open this up in CFF Explorer and look at the section headers. If not, I would like to go in Dependency Walker and see. Okay, so again, I'm seeing the same URL download to file. The kernel 32 has the winexec, get temp path, and get windows directory. So this binary contains what we analyzed earlier in the main process. So this is the file that contains these imported functions, which we can see down here. I want to know what the url.dll does. So if I go back to my appendix and I URL download to file, right? So a high level call to download a file from a web server and save it to disk. This function is popular with downloaders because it implements all the functionality of a downloader into one function call. And it contains the winexec function as well as the get temp path and get windows directory. So we can see based off the winexec and the URL mon DLL, the URL download a file function, we can see that this is most likely going to execute it's going to download a file and then execute that file. So that's what I'm going to say I can tell from this. The resource contains the download file function and winexec function indicating the resource may download a file and execute it on the system, right? So based off of that information, I would like to look at the answers that are in the back of the book. So again, starting at question 1, as of his writing, 16 out of 43 antivirus engines detected this. In our case, we had 64 out of 72 security vendors flagged this. And he also indicates in question 1 that the security vendors analysis on VirusTotal, that it indicates that it downloads or drops additional malware onto the system, which we figured out through our static analysis. Question number 2, I said it's not a pack sample, and he said there are no indications that the file is packed or obfuscated. Question number 3. So his answer to question number 3, this book was written a while ago, but way before 2019. So according to the file header, this program was compiled in August 2019. Clearly the compile time is faked. So for me, I didn't know that because it's 2024 currently, but in his case, it was a future date and we can't determine when the file was exactly compiled. Question number 4, the imports from advapi 32 DLL indicate that the program is doing something with permissions. The imports from winexec and write file along with the results from VirusTotal tell us that the program writes a file to disk and it executes it. There are also imports for reading information from the resource section of the file. And we took note of the winexec, which shows that it does execute a specific program or process. There are also imports for reading information from the resource section of the file, which, yeah, I can see the load resource. It looks to be like I'm on the right track here. So for 5, what host or network-based indicators could be used to identify this malware on infected machines. He says the string system32 WUPD manager.exe indicates that this program could create or modify a file could create or modify a file at that location. So we noted that. And then he also says the string www.malwareanalysisbook.com/updater.exe probably indicates where additional malware is stored ready for download, and we took note of that HTTP link. This file is one resource in the resource section. Use Resource Hacker to examine that resource and then use it to extract the resource. What can you learn from the resource? He says the resource contains another P executable. Using a resource hacker to save the resources as binary data and then analyze the binary file as you would analyze any executable. The executable in the resource section is a downloader program that downloads additional malware. The resource contains the URL download file function and exec function indicating that it may download a file and execute it. So we were on the exact path on that too. That is the last lab of the first chapter, and I will have to do additional reading. And chapter 2, once I get to those labs, expect more content on this. Thank you guys for being here and watching the video. Looking forward to doing more analysis.